welcome to Chatterbytes. Today is another episode of Fun with Science. Today's lesson is tension, oh tension, surface tension. That's right. Today we are going to learn about surface tension. And I gotta say, during these experiments there were a lot of tense moments. Now let's learn about surface tension. Let's get started. So I have a lot of things here. I have a jar, I have a liquid dishwashing detergent. Then I have a foam dice, a really small foam dice, bottle of water, and a jug of water. Really don't know why I need so much water. I can feel even more tension. Anyway, I have some cards, an old birthday card I received from a friend, a napkin. I'm starting to begin to think she's gonna splash me with water. Some Q-tips, a quarter, and a ping pong ball. Okay, so I have this perforated bag. I have 4 of these push pins. They're extremely pointy. See, they're extremely pointy, so I have to be careful with them. I'm going to place them in this cup and keep it at a safe distance so no accidents happen. And then I have this perforated bag and this is a jar full of water. So my mom told me to pour the water in here and see what happens. Obviously, it's a no-brainer. I mean, this bag is full of holes. In fact, when I pour the water, I think it's just gonna go, there's so many holes in this, I think the water's just gonna go right through it like it's no big deal. Okay, so I'm gonna pour the water in. Obviously, we all know what's gonna happen since this bag is full of holes and perforated. Yep. See? It just went through like it's no big deal. No magic here. And that was plain H2O. Filled the jar back with water. So then the next step is to take this bag, the same perforated bag we used last time, and cover it over this. So then, and I take this cap, and remember this is a mason jar cap. Remove this, then put this up here. Then tightly onto the mason jar so none of the water might not leak out. Done. Slowly pour it. See? The water still leaks out because this bag is still perforated. Now, I add these pins into the water, into the holes in this perforated bag. They're not going to do anything because this bag is not punctured. So, I'm going to put those in. And let's see what happens. Okay. So, we know that the water just passed through because this bag is perforated. But this isn't the end of this experiment. The next step is the prime part of this experiment. I'm really nervous, and this is all where the maximum tension is. So, but for it to work, I need to refill this bottle with water. So, I'll fill this, and I'll be back in a jiff. Okay, so I filled the water again. I put the perforated bag to cover the jar top. And the step is, I have to take this card, cover the top with it, slowly flip it over, then slowly release it. What? Okay, what? Do you see that water? How is that possible? I mean, a few drips got in, but other than that, it's still floating. It's as if the water is just like hovering there. It's like defying the laws of physics. So we're gonna invert in 5, 4, 3, 2, 1, flip. Remove the cup. Wow, how is that work? Oh reduce it. No. There's 1 pin. There's 2 pin. There's 3 pin, and it still has not popped. Then there's the final pin. Wow, that is impressive. Now I'm gonna flip this bottle over, and I'm gonna try and do that. I'm gonna try and do that one again. Let's see if it works this time. Okay, so I did some research, and according to USGS.gov, surface tension is when the water molecules stick together, creating like something kind of like a skin for the water that you can't see, but it keeps the water from easily falling out or creating droplets. So here's another way to here's another example of it. If you drop in this paper clip, see how it falls down? That means there is no surface tension. So I'm going to try and create surface tension by ripping this tissue piece, dropping in, and quickly placing this on top of it. Ooh, see? Look, if you notice, the paper isn't helping it at all. Paper tissue has moved away, and still the paper clip's moving. That means we have created a surface tension. To show you, I'm going to carefully take this piece of tissue out, and ta-da! See? Even now, it's still floating. Still. Okay, so this next one is one I like to call the deodorant rollers. Okay, so I take the ping pong ball, keep it here, and to keep it from going, this like this. So here I have the deodorant, this looks like a deodorant because this bottle stays here, and if you carefully pull it, twirl this, see, the water can roll around on the ball, but it can't leak out when it's held upside down. For my case, to exit this mode, just squeeze the bottle. So when you squeeze the bottle, the molecules that created the surface tension are broken, hence releasing the water and causing the ball to fall out, and hence releasing the water. And this is another trick for surface tension. So I have a jar of water that's 75% filled with water. It's not filled to the brim because I don't want to create surface tension between the card that we're going to put here and the water. So you take the card, you place it here, then you take the dice and place it here and see what happens. As we all know, the dice is heavier than this side, and since the water molecules can't get a grip onto the card, since it's not, the water molecules can't reach far enough to get to it, the weight of the cube causes it to fall over. But let's see what happens when I fill it to the brim this time. So I take this bottle of water and use the water in it to fill this jug to the brim and to create surface tension. There, that's enough. You take the card and place it halfway through. Then you take the cube and see what happens. Ta-da! See? Even though the weight this side is heavier and should fall over, the water in the jug is high enough to get a grip onto the card, keeping it from falling over. Another trick is you take a quarter and a dropper. You take the dropper, fill it with water, then drop the water onto the coin. says surface tension keeps the water. The surface tension prevents the water from getting off the coin and keeps all the water on the coin. Thanks for watching. This episode was truly tensional tension. I hope you enjoyed learning about surface tension with me. If you liked this video, please like, share, and subscribe. Until next time,